Hey, we're going to go to math.com, click on the algebra, let's go down to quadratic equations, and we are looking, I guess we're looking at 8.1. Yes, I think that's it. And what is that? 8.1. So we have 4x squared minus 64x plus 90 is equal to negative 2x squared. Negative 2x squared. Okay. What do we need to do? Let's go over here. That's where we need to be. So 4x squared minus 64x plus 90 is equal to negative 2x squared. And you know what? We got Pi Day coming up, which is 3/14. And I have decided to run a contest on that day on my main YouTube page of the introduction video. There will be a encrypted math message. I'm writing these equations out because it reminds me of that, and figure out the encrypted message and win, and I shall send you cash in the mail, or however we're going to do that. Okay, so what do we need to do? Let's get this in the standard form, and I think I'll do this every 3/14. Let's take this and bring it over to the other side. We'll make it an annual thing. I hold contests doing geocaches. You may not know what that is, but I think I'm going to just skip that this year and do a contest on my YouTube channel. That's it. Alright, so we brought this guy over here to this side, and since this is negative, we take it over to the other side, it becomes positive. Right? So let's collect up some like terms. We've got 4, 5, 6x squared minus 64x plus 90 is equal to 0. Let me go ahead and erase that. That's not part of the problem. That's not a clue. Now here's what we need to look at first. Okay, is there something we can pull out of here? Does 6 go into 64? Does 6 go into 90? In other words, let's find the GCD. That's what we want to find. Is the GCD of 6, negative 60, or 6, 64, and 90. Okay, 6, 64, and 90. And you know what? I have got a built-in GCD function for this. I think it's small GCD. What was it? It was 6, 64, and 90. Let's test it out. Ooh, I hope that doesn't interfere with our problem. And you know what? Crud. I think it's a capital GCD. 6, 64, 90. I guess it might be 3, huh? Oh, it's 2. Okay. So we can pull a 2 out of there. Alright, well, let's go back. 2. Yeah, that's 45. Okay. So this is what we'll want to do here. So that's going to make that a what? 3, so that's good. 3x squared minus 32x plus 45. That helps out a little bit. Helps out. All right. So we go through this systematic approach. Right, we've devised an algorithm. How's that? That helps us minimize the amount of time taken to solve such a problem. So I'm going to write down 3 over here, And we know that we can factor that up. And it's definitely not 2, that's for sure. But 3, right? 1 times 3 is 3. And then let's look at what's the next one. Whoa, 45. Okay, so we got 1 and 45. And then we got 9 times 5. And actually, let's see, that could be broken up to 3 times 3, 15. So 3 and 15. All right. There's a lot of possibilities there to go through. So remember, we need two numbers that when multiplied together is going to give us, what, 45? Okay. And we're going to let this number be A and this number be B. Okay. So we've got 3 times B plus, right, A. And that's going to be equaling, negative 32. Negative 32. Hopefully that's on being recorded there. Still on the screen. Alright, so we go through. Let me rewrite. No, we don't have to rewrite. What am I doing? Alright. So we go through the possibilities here. Negative 32. So that means that this number here has to be larger than that number for that to be a negative. So that means that B must be negative, right? Obviously. Oh, that's exactly what that means. That must be negative. And then that's going to be positive. Or is that true? Well, if that's not, that's not necessarily true. Erase that, erase that. Okay, so let's just go through our possibilities. 1 and 45, right? If I put a 1 here, 45 here, wow, did I get that off the 1 minus 45 is negative 32. Wait a minute, that's got to be a positive number. That means both numbers have to be negative. Both numbers have to be negative. I should have seen that. Okay, so that was close, but not but that's not going to work. That is not going to work. Right? 45. Okay, well, we know it's not 1 and 45, so we can cross 1 and 45 off the list, right? What about 9 and 5? So if this were a 9 and a 5, they'd both have to be negative now. Okay, because a negative times a negative is a positive number. So that's going to be 27, and 27 and 5 is, wow, that's 32, isn't it? 27 and 5 is 32, how be darn. Okay, so I think we found it. We found 9 and 5, negative. So B is negative, negative 9, and A is a negative 5. All right, so let's take a look at this. So 3x times is negative 27, and negative 27 minus 5 is negative 32, and negative 5 times negative 9 is positive 45. Alright, so we got lucky on that, I feel. So we want to set both these equal to 0. So 3x minus 5, therefore x is equal to 5/3. And then, of course, let's erase that. We set this equal to 0, and we got x is equal to 9. I should be circling these guys. 5/3 and 9. Wasn't too bad. What did I say? 5/3 and 9? Yeah. 5/3 and 5/3 and 9. Okay? Alright, that was way too long.